There are three types of current that we're going to focus on that is used in electrical stimulation. The first current we'll talk about is direct current. Direct current means that there is a one direction or unidirectional flow of particles that lasts for at least 1 second. If we go down to the image here, the red line represents direct current. So it's a single unit of charge. This upper line here represents the positive side. So we're delivering kind of a positive charge into the tissue. If we go back to the concept of a charge building up in the cell, this is a situation where you're sustaining a direct charge over time. This produces a cellular effect, a circulatory effect, and is the means by which we push medication underneath the skin using electricity. So we've got a buildup of charge. You really see it most commonly in wound care and with iontophoresis. And next week we'll talk about iontophoresis, which is using a charge to push ionized or charged medications underneath the skin to treat the target tissue. Another example of direct current that you might see referred to on commercial units as well as the literature is microcurrent. Now there's also this monophasic direct current that you'll see on units as well as in the literature, and that's represented by this green waveform here. So monophasic means you've got a single phase, means it never alternates, it never goes into the negative realm, it just stays in a single phase. However, it's interrupted, so you'll notice here we have these two green arrows and then it stops. There would be a pause and then it would resume down further. So unlike direct current, which is continuous for at least a minute, monophasic pulsed DC current means that you have a single phase where it's going up and down, never crossing into the other phase. However, it is interrupted. So in less than a minute time, there's a pause and then it may resume further down the road. The next type of current we'll talk about is alternating current. So that is a bidirectional flow of ions, and that's represented by this blue wave. And so you can see that there's a positive waveform and then a negative waveform, and that repeats. The poles alternate from positive to negative, and it moves down the line. And the rate with it switches between positive and negative is the frequency. The thing that's the distinguishing thing to know about alternating current is because the charge alternates, although you may have a depolarizing stimulus, what you do not get is a buildup of charge in the tissue. So there's no buildup of charge underneath the electrodes as the electrical stimulation is being administered. When you're working with commercial units, you can have different types of alternating current. There's a common current called Russian current. This is a current we use to stimulate muscles to contraction, and that's burst modulated. So you'll see a bunch of waveforms coming in, and when they come in, they may come in at slightly different frequencies. Interferential current is an amplitude modulating current. Interferential current, we'll talk about when that's used later on, but it's considered an amplitude modulating current, which means the height of the waves can differ slightly between phases. So that's a nice feature to kind of increase the comfort and decrease accommodation. And then finally, as I've already mentioned, you can have pulsed current. We can have pulsed alternating current and pulsed direct current. When you hear monophasic talked about in the parameters on different commercial units, that is where you have a current that does not alternate. So this again allows a charge to accumulate in biological tissue. If it's pulsed alternating current, because you'll spend just as much time in the positive as the negative, a charge will not accumulate in biological tissue.